Hi guys, let's go ahead and look at 2.9. So if you're going to be in school this week, this is the one we would do in class together. If you're absent, then you want to go ahead and watch this video so you can keep pace with what we're doing in class. We don't want you to fall behind because you were absent. 2.9 is about proving lines parallel. Remember that we've just talked about parallel lines and transversals in 2.8. And so now we're going to kind of do it backwards and say, if the two relationships are true, then that must mean that the two lines are parallel. So we're kind of taking it backwards from what we did last week. All right, so we've got on the front several Converse, which means like in reverse, postulates and theorems and stuff we'll write out. And the very first one is called the converse of corresponding angles postulate. Okay. I lost my pencil. Okay, postulate. All right, and what it says, if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. That's the opposite of what we did last week, where we said if two parallel lines are cut by a transversal, then those corresponding angles are congruent. So now we're working it backwards. We're saying, well, if the corresponding angles are congruent, then those lines must be parallel. Okay, so we can take this thing and move it both ways, but they call it converse when we start from this end. If we have two lines and we're not putting the little arrows on them to say they're parallel because we're starting off with they're just two lines. We don't know if they're parallel, so don't put the little arrowheads on. Cut by a transversal. Woo, I am popping lead everywhere. Cut by a transversal. Okay. If corresponding angles are congruent, so let's pick any two corresponding angles. How about this guy and this guy? And I'll even just color them in. This angle and this angle. Remember, corresponding means they're in the same position in relation to their line. So these two angles are both under the line to the right of the transversal. If those two are congruent, then we know the lines are parallel. Okay, so if you kind of understood what we did last week, we're doing it backwards. We're taking it the other direction. The next one is called the parallel postulate. Parallel postulate says, if you're given a line and a point not on the line, then there's exactly one line that can run through the point and be parallel to the given line. So let's see what that looks like. If we have a line and a point not on the line, how many lines can you draw through that point that would be parallel to the line we already have? So we wouldn't want to draw a line down that connects to it, or even like perpendicular, anything that intersects is not going to be good. Only one line will run through and be parallel to the other line. I'm going to put here only one. If I took that line and I tilted it just a little bit, then it would eventually hit the other line. If I tilted it just a little the other way, same thing, eventually it would cross this second line. So there's really only one line that would never intersect the first one that we can draw through that point. That's the parallel postulate. All right, let's go down to these next ones. Proving lines parallel. So we'll put some titles on here and draw some pictures to go with it so we kind of understand what we're looking at. This first one, if two lines in a plane are cut by a transversal, we don't know if they're parallel. so that a pair of alternate exterior angles is congruent, then the lines are parallel. So that is called the alternate exterior angles converse. Because we're working it backwards. We're going from, we know the angles are congruent, to then the lines must be parallel. So let's put on here, if, and we'll draw our two lines, but don't mark them as parallel. We don't know yet. We'll put a transversal on there. And then let's mark two alternate exterior angles. I'm going to pick this guy and the alternate other side of the transversal. Those are two alternate exterior angles. If they're congruent, then we have parallel lines. And if you look back at section 2.7, we did it the other way. We said, if two lines are parallel, then the alternate exterior angles are congruent. So now we're saying, well, then if they're congruent, the lines must be parallel. So we're just doing it backwards. Let's do another one. If two lines in a plane are cut by a transversal so that the consecutive interior angles are supplementary, then the lines are parallel. That's called the consecutive interior angles converse. Converse meaning we're going backwards from what we did last week. All right, and it would look like this. If we have two lines cut by a transversal, we don't know if they're parallel yet, but let's say this is angle 1 and this is angle 2. If the measure of angle 1 plus the measure of angle 2 equals 180 degrees, then our lines are parallel. And I'll write parallel out here. Okay, that was one of our postulates and theorems from last week, that if the lines were parallel, then the interior consecutive angles added up to 180. So now we're saying, well, if they add up to 180, then the lines must be parallel. Next one. If two lines in a plane are cut by a transversal so that a pair of alternate interior angles is congruent, then the lines are parallel. All right, that is the alternate interior angles converse. Alternate interior. And we'll draw it if we have two lines cut by a transversal, and we're wondering, are they parallel? I'm not sure. But we do know alternate interior. Let's draw some alternate interior. So here's an interior, and then the alternate is on the other side of the line. So this side, if those two are congruent, comma, then we have parallel lines. Parallel lines. Lines are parallel. Okay. And we know one more. In a plane, if two lines are perpendicular to the same line, then the lines are parallel. I don't think we did one like this. This one's different. If two lines are perpendicular to the same line, so that same line must be the transversal, two lines and a transversal, then the lines are parallel. This one's called the perpendicular transversal converse. Transversal converse. Okay, and it would look like this. If two lines, and it says if two lines are perpendicular to the same line, so our transversal will be perpendicular to those two lines. So both lines are perpendicular to that transversal. Then the lines are parallel. And if you think about it, that kind of makes sense. If they both form a 90-degree angle with this line, they'd have to be the same slope or go in the exact same direction. All right, let's turn it over and look at the back side. Make sure we get that there that you can see. Okay, given the following information, determine which lines, if any, are parallel, and then state the postulate or theorem that justifies our answer. Okay, let's look. We want to check angle 2 and angle 8 are congruent. So I'm just going to draw that this guy and this guy are congruent. Then we have to think about the different rules that we know. And what I see when I look at that is these two guys, if I look at A and B as the two lines, and I look at angle F as the transversal, then they are on opposite sides of the transversal and they're interior. So alternate interior angles. And if they're congruent, then that would make line A and line B parallel. So for that one, I ignored line M, and we can do that. We can pretend like some lines aren't there for a little while. If we call A and B the two lines that we're checking, and angle 2 and 8 are alternate interior, and they're congruent, then according to that converse theorem, we can decide that A and B are parallel. So I'm going to write that. A is parallel to B, and the rule we're using is the alternate interior. Interior, I'm shortening my words, converse. Okay, let's do another one together and we'll let you try. Actually, we'll do a couple more and then let you try. This one says angle 3 and angle 11. I'm going to erase the ones that I did so I can see this better. Angle 3 and angle 11. Okay, so what relationship do they have? Gotta look at that and think about it. I think I'm going to cover up B and pretend like he's not there, which would mean these are my two parallel. These are my two lines that I'm checking to see if they're parallel. And then this would be the transversal cutting down the middle. And these two guys are in corresponding spots. They're both below their line and they're both to the right of the transversal. So if they are congruent, then that would mean these two lines have to be parallel. That's the corresponding angle converse. So I'm going to use that one and say, this time it's angle, or it's line. I can't tell if that's an L or an F. I'm going to say L. L is parallel to M. Okay. And I decided that because the corresponding angles, so corresponding, and it's the converse that helps us prove lines are parallel. All right, let's do this one then. I'm going to erase that so I can do another drawing on here. Angle 12 down here, congruent to angle 14 out here. Let's see, I think I will cover this up. So that's not part of my picture anymore. And I see these are the two lines then. And these angles are on alternate sides of the transversal and they're exterior to the whole thing. So alternate exterior angles, as long as they're congruent, that means our two lines are parallel. It's the same lines we started with, A and B. A is parallel to B, and I used alternate exterior converse to prove that. All right, now we'll do one more together and then let you try the next two. This says angle 8 and angle 6. Where are those guys? Here, angle 8 and angle 6. So if I know that they're congruent, which makes sense because they're vertical angles. I know you guys learned about that before. Vertical angles, but there's not any theorem that says if two vertical angles are congruent, it proves anything parallel. So they're not corresponding. They're not next to each other in between. So they're not consecutive interior. They're not alternate interior. They're not alternate. They're really nothing. They're not. And so I'm noticing back in here, it says, if any, determine which lines, if any, are parallel. And that's actually a trick question. There are no, so we'll put none. No lines that we can determine are parallel with vertical angles. That just tells us we have two lines that cross, that intersect. So let's erase that one. All right, pause your video and try these next two, and then come back and we'll check them. All right, let's see what you did. Measure of angle 8 plus the measure of angle 13, here's 8, equals 180. I like that one because there's only one that says if they're supplementary, they must be parallel, and it's the consecutive interior. So if those are right next to each other, I'm going to cover this line up for a second. These are consecutive interior angles. That means line L and line M. L must be parallel to M, and we used our consecutive interior angle converse. Let's see, I should do angle converse to prove that one. Okay, because they're right next to each other and they're interior and they add up to 180. Last one is angle 8 and angle 16. So if those guys are congruent, cover that up, they are in corresponding spots, and that would prove that angle L, and angle M, line L and line M are congruent by the corresponding converse. Okay, so that's how you would do that. You're proving lines are parallel by taking those relationships and using them in reverse. Let's try this one. Find the measure, or finding what x is equal to, and the measure of angle ZYN. ZYN. So that's this guy out here. What's this angle? So that PQ is parallel to MN. So we want to prove that these two are parallel. To do that, we would have to show that, they gave us these two alternate exterior angles. If we could make them equal or congruent, then our lines would have to be parallel, because according to that Converse theorem, when alternate exterior angles are congruent, the lines have to be parallel. So actually that's the postulate that we're going to use. We're going to say the alternate exterior angle converse, going in reverse. Okay, using that, we can make these two alternate exterior angles equal to each other. And then the question says find x and find the measure of ZYN. So we'll need to plug it into ZYN at the end and get that measure also. All right, let's solve for x. This is back to your algebra days. You want to get all your x's on one side. I always like to subtract the smaller number. It just seems like then I can keep things positive on the other side and it's easier. All right, x is on one side. Let's get our numbers moved to the other side, away from the x. 4x equals 60. All right, we know what 4x's are, but we want 1x. So we divide by 4, and x equals 1, 5, 15. So we solved that. Let's put a box around that. And then the last part says find the measure of ZYN. So we'll need to take our x and plug it in to that formula that they gave us for the measure of angle ZYN equals 7x plus 35, or 7 times 15 plus 35. What's 7 times 15? You know, I might need a calculator for that one. 105 plus 35. And then we add that together, 140. So that is the measure, which means we need to go ahead and put a degrees symbol on there. The measure of ZYN is 140 degrees. All right, you guys, there's one more here. It's for you to try. Pause your video and see what you can find, what relationship you can use to make those two lines parallel. Okay. All right, let's go ahead and check on this. It says find y so that E is parallel to F. Okay, we've got two angles here. They're in corresponding positions. So let's talk about the corresponding converse, corresponding angle converse. If corresponding angles are congruent, then that means that they are equal to the lines are parallel. So I'm looking and wondering, I'm feeling a little confused here. Let's get rid of this. I don't think he belongs there. We have a 90-degree angle because it is, it's got the little mark for perpendicular. So 90, and since they're corresponding, they should, if they are congruent and they're corresponding, then our lines will be parallel. So 4y plus 10. If we make that happen, which we have the power to make that happen, then we can solve for y, and these would be congruent, and our lines would be parallel. So let's move that 10 to the other side. 80 equals 4y. All right, and then we don't want to know what 4y is. We want to know what 1y is. Y equals 20. We could also call that, I'm thinking as I look at it, it's the corresponding angle converse, but also there was that one about perpendicular. The perpendicular, I'm going to say or, because you might have thought of this one when you looked at it, perpendicular transversal converse. That would describe that situation also, since the one is perpendicular and we forced the other one to be perpendicular also. So there's actually two ways that you could think about solving that one. But it did ask us to also find what the measure of y is. So it's 20. All right, you guys can go ahead and get started on that assignment. For this week, it's 2-9 and 2-10. So if you're in class, you did 2-9. If you're at home, you need to do this 2-9. And then 2-10 is all at home, no matter which way you go. See you guys next time. Bye.